Question 9. Now, with these problem-solving differentiation questions, this is a classic final question on a C2 paper. And my tip to you would be to leave your problem-solving part A until the very end, because that's a bit hit or miss. I mean, I will talk you through that, but I think I want to focus on parts B and C, which is just so much more straightforward. So use calculus to find the minimum. So basically, we're going to have to differentiate this and make it equal to 0. So first of all, get it ready to differentiate. Take the r upstairs ready. So we're getting 300 pi to the r to the minus 1. So that's what c equals. So differentiating c with respect to r, so we multiply by the current power, reduce the power by 1. We're at 12 pi r, and then set with the second term, again multiply by the current power, minus 1 times 300 is minus 300. Reduce the power by 1, we get r to the minus 2. Or in other words, our second term is minus 300 pi over r squared. Now, at a maximum or minimum, we set this differential to equaling 0, so this equals 0. So I then added 300 pi r squared over r squared to both sides, giving me 12 pi r equals 300 pi over r squareds. Now my pi's cancel. I've then chosen to multiply through by r squared, so I'm getting 12r cubed equals 300. Divide both sides by 12, I get r cubed being 25. Cube rooting 25, I get r to be 2.924. So that's what my radius is. Now I've been asked to work out the minimum cost, so I substitute this radius into my cost formula. So I'm substituting my 2.924 into this cost formula, giving me 483 to the nearest pound. Now part C, justify that it's a minimum, so you want to take the second differential and prove that it's greater than 0. So there's my differential from up here, and so differentiating again, my first term becomes 12 pi, my second term multiplied by the current power, so minus 300 to minus 2 is plus 300, reduce the power by 1, so this becomes r to the minus 3, or in other words 600 pi all over r cubed. Now r is obviously a positive number. I mean well, we know our r cubed is from up here is 25, so actually our second differential is going to comprise 12 pi plus 600 pi over r cubed, but r cubed is 25. Now this is positive, so clearly this is greater than 0. Therefore it's a minimum. So part B and part C, very straightforward, well, comparatively straightforward. Now back to part A. We need to show this formula. So what do we know? We've got a cylinder and we know its volume is 75 pi. So a volume of a cylinder, it's just like with any prism. Step 1, you work out the area of the end bit, which with regard to a cylinder is a circle, so pi r squared. And step 2, multiply that by the height of the cylinder. So our volume is pi r squared times h, and we're told that is 75 pi. So cancelling the pi's, we get r squared h equals 75, or having divided through by r squared, we get h equaling 75 over r squared. So let's just park that for a moment. Now let's move on to starting again. Let's work out the cost of polishing the amplifier. So let's first of all think about the curved surface area of the cylinder. That comprises the actual area of that is the when you imagine flattening out the curved surface, you end up with a rectangle where one length is the circumference and the other length is the height of the cylinder. So that's 2 pi r times h. Now the cost of this, as it's £2 per centimetre squared, is 2 lots of that, which is 4 pi r h. Now what about the cost of polishing the two circles? Well, a circle is obviously pi r squared. We've got 2 of them and they cost £3 each, so the cost of that is 6 pi r squared. So the total cost, the 2 circles, is 6 pi r squared, plus the cost of the curved surface area is 4 pi r h. Now we're nearly here. We just now go and substitute in that we know that h is 75 over r squared, so that substitutes in here. That r cancels with one of the r's on there, so we're left with 6 pi r squared plus 4 times pi times 75 all over r, which is what we had to show. So not that easy, and obviously every time you do one of these papers this bit's going to be completely different, so this bit is very hard to practice. This isn't. So make sure you always do the calculus bit first, and then come back to the problem solving if you have time.